black rectangle. Okay, is that good? Okay, there's that one. What else is intermediate? Which one? H2, yeah, circle, well, oval, whatever. Okay, those two. Anything else, or did I get all of them? Which one? Oh, B2H6, yes. I'll put a cloud, or, maybe for you, a sheep. Okay, is that everything? Okay, those are all my intermediates. I have 1, 2, 3, 4. Okay, 4 intermediates. If I asked me for the intermediates, I would just list those. Okay. Now we also want the multiplier, so that I want these 4 reactions to add up to this one. There's 2 basic steps that you need to follow in order to make that happen. One is, and we'll do these in just a moment, I want to match these and their coefficients with what I see up here. The other thing you want to do is to make sure that intermediates can't go into added. So you can do those 2 kind of general principles in any order that's helpful to you. So let's just do easy order. That sounds good to me. What I like, one easy thing to do is just look down here and see if what you see down here matches with up here. For example, there's 2 borons I need in the reactants at the end of the problem. Is that okay? And this one has 2 borons in the reactants. So I actually want to take this reaction here and not change it. Or times 1. Just to remind myself, I'm not going to change that last reaction because I need 2 borons in the reactants. Okay, now, let's take a look at, I also have B2O3, and I have that up here. I need, remember this is my final correct answer, I need 1 of these in the products. But I have 1 in the reactant up here. Does that make sense? So what's going to happen to this first reaction? You have to flip it, and mathematically that happens, oh, let's just continue with blue. When I multiply by -1. I'm going to multiply times -1. That means I'm flipping that reaction. So that the B2O3 will be on the other side. Okay. Now, I could go on to oxygen next. One problem with that is this oxygen appears here and here. So it appears a couple times, and it would just cause more algebra to occur in my head, more than I would prefer. So because of that, I'm going to use the other principle now in order to have a multiplier for the middle 2 reactions. What I want is I want all the intermediates to cancel. So I'm going to pick an intermediate now. I'm just going to basically pick an intermediate that is in one of the reactions that's set with a multiplier, and having the same one in one of these reactions that's not set yet. So for example, I would not pick water liquid because it's in just the middle 2 reactions. But I would pick, for example, a water gas. That one's fine because I'm already set with the first reaction with a multiplier. I just need a multiplier for this next reaction. So there are right now -3 waters in the reactant side, or if you want to say a different way, there's 3 waters in the product side. Okay, what do I need to multiply this by, the second reaction, such that all those water gas are gone? Okay, let's see if this makes sense. A lot of people are saying -3. If I times by -3, I'm going to have, is this going to work? I'm going to have -3 here, and I'm going to have -3 here. Will that cancel? That looks good. There's a -3 on the left side cancel with a -3 on the right side? Okay, I'll say it again. There's -3 on the reactant side of these. Is that okay? 3 times -1. And there's -3 of these on the product side. Okay, just in case, you guys are freaking me out right now. X minus 3 equals -3. Would I not cancel those? Okay, that's what I'm doing. Okay, cool. Okay, just to do an algebra example. All right, now I'm going to the last one. I'm going to pick H2, because I have, say, H2 here and I have H2 here. That's a nice one to work with. And I really could have picked either. Now, I want those H2s, again, to cancel, because they're intermediates. All intermediates must cancel. How many H2s do I have in the reactants right now? Just 3, because it's multiplied by 1. So, what do I need to multiply this by to make it cancel? Okay? Times by minus 3. Let's see if that works. I'm going to have 3 H2s in the reactants. And up here, I'm going to have minus 3 H2s. A minus 3 plus 3 is 0. There we go. I have my multipliers. Minus 1, minus 3, minus 3, 1. So I'm done. I have all my intermediates. They're all the ones that are shaped there with the shapes or animals around them. And so I'm finished. And this was, if you have the practice exam reader number 18 on page 19. Okay. Any questions about this one before I move on? This is more like a medium difficult question. Yeah. The answer is these multipliers, minus 1, minus 3, minus 3 plus 1, for the multipliers. That was one question. And for intermediates, I would just list everything that has a shape around it. H2O gas, there's H2O liquid, there's H2 gas, there's B2H6 gas. Same thing? I think that's everything. Is that okay? Good. Good question. They do. If, for some, like we never looked at the oxygens is what he's saying up front. And if you look at them, they will actually work out. If you have all the multipliers, if it works for one set of, whatever principles you're working on, it'll work for the rest. So it should all be clean, nice and tidy at the very end. All the intermediates will cancel, and everything will add up to this, and everything will match with these numbers. So if it's one of those doesn't work, either you're misadding something after you put your multipliers, or you have the wrong multiplier. Okay. Cool. Let's do the next part. What's next? Isotopes is what I wanted to do next. Isotopes. This out of the way. There are a couple of types of isotope questions. They all go under the same principle as the atomic number. The larger number in the periodic table that's next to the elemental symbol is going to be the sum of the percent abundances, which really you're dividing by 100 to change it to a fraction, and the isotopic problem. So one type of problem, we give you every isotope, and we give you every mass and every percent abundance. You add them up to get this number. That's one way to do it. The other way to do it is really doing the problem backwards. So you have the atomic mass either given, or you take it from your periodic table that's going to be given on the exam, and you solve for one of these. So the easiest question is we give you all this information, you solve for this. The next slightly harder question is if we drop out one of the isotopic masses. So in that case, you would just add things up and solve for this. In some cases, when we don't give the percent abundance, that's typically for most people the hardest problem. So let me just go over that example. Let's say we have mystery element E. That's a good letter. And it has 2 isotopes. So isotope 10 and 11, for example. Okay? And you don't have the percent abundances, but let's say you have the isotopic masses. Let's say this is 10.1, and let's say this is 10.9 U, for example. Okay? And we know that the atomic number of this mystery element is 10.5.